Today we are going to learn Newton's second law of motion. Let us understand what do you mean by the term momentum of a body. You must have noticed fast bowlers taking a run up before bowling, and by doing so they can bowl the ball up to 140 km per hour. The reason they do so is to gain momentum. Now, having the knowledge of momentum is very important for athletes. What is momentum? Momentum is defined as a product of mass and velocity of an object. It is usually denoted by P. P is equal to mv. That's a mathematical expression for momentum, where P is momentum, m is mass of a body, v is the velocity of a body. Momentum is a vector quantity, which means we must provide both magnitude and direction while describing momentum. Since momentum is a product of mass into velocity, and velocity itself means a speed of an object in a particular direction, and therefore velocity is a vector quantity, and hence momentum is also an vector quantity. Suppose a car is moving in west direction with a velocity of 20 meter per second. Let's find out its momentum. Then, according to the equation, then momentum can be calculated as P is equal to mass into velocity. The mass of the car is 500 kg and velocity is given as 20 meter per second. So by substituting the value, which will be equal to 500 multiplied by 20, which will be equal to 10,000 kg per meter per second in west. So if a body is at rest, its velocity is 0, so its momentum is also 0. The SI unit of momentum is kilogram meter per second or kg meter per second. It is also written as kg ms raised to the power minus 1. A moving object can have larger momentum if either its mass or velocity or both are large. Let's see mass, how mass is going to affect the momentum. A cycle have a smaller mass, whereas a car have a larger mass. A moving car can kill a person because its momentum will be large, but a moving bicycle will do lesser harm since its momentum will be small. So here the two objects having different mass, one is having the larger mass will have the larger momentum, and the object which have the smaller mass will have the smaller momentum. Velocity of an object also determine its momentum. If two cars of the same mass are moving with different velocity, then a car with a higher velocity have a larger momentum, which means if a car A moves with a speed of 120 km per hour, then it can kill a person. But another car with the same mass, let's take an example. Let us consider this car as B. So another car B, if moves with a velocity of 10 meter per hour, then it may not kill a person. So the impact or the momentum generated by car B is lesser compared to the impact or momentum generated by car A, which is moving at a speed of 120 km per hour. Therefore, from this illustration, we conclude that velocity of a body determines its momentum. Similarly, in this example, a huge ship moving at a slow speed, but in this case, its mass is very large. Therefore, the momentum of this ship will also be very large. The impact produced by this ship will be larger. Also, a bullet moving at very high speed will have a similar momentum as that of a ship, because in this case The object is moving at very high velocity. Although the mass of the bullet is very small or very less compared to the massive huge ship, but it's moving with a high velocity. So velocity and mass plays very important role in terms of momentum. So momentum can be described as product of mass into velocity, and the two factors that determine the momentum is mass and velocity. If the mass is large, the momentum will be large, and vice versa. Similarly, if object moving with higher velocity will have more momentum than the object moving with lesser velocity. So momentum can be understood as the amount of impact the moving object can cause. Higher the momentum, higher the impact. Let's consider example. A car with 1000 kg mass and truck of 3000 kg mass. So when a car and truck are traveling at the same speed, the truck has more momentum and it has larger impact. Therefore, when both collide each other, the momentum generated by the truck will be more since its mass is more. Thus, truck can cause more impact and more damage than the car. So, Newton's second law of motion states that the rate of change of momentum of a body is directly proportional to the applied force on it, and this change in momentum takes place in the direction of applied force. So mathematically, we can write the Newton's second law of motion as F is equal to kma, where k is a constant of proportionality. So in other words, we can say that F is equal to m into a. The SI unit of mass is kilogram and acceleration is meter per second square, or ms raised to the power -2. So the unit of force is kilograms meter per second square, or Newton. Its symbol is N. Newton's second law of motion is often seen in action in our everyday life. You must have noticed while catching a fast moving cricket ball, a fielder in the background gradually pull his hand backward with the moving ball. In doing so, the fielder increases the time during which the high velocity of the moving ball decreases to zero. Thus, the acceleration of the ball is decreased, and therefore the impact of catching the fast moving ball is also reduced. If the fielder do not move his hand backward, then the fast moving ball can cause damage and his hands can get hurt. Now let us try to understand Newton's second law of motion. If we apply more force to an object, it will accelerate at higher rate. It means that if we apply more force, the object will move faster. This also means that when more force is applied, the speed will increase. Now if we increase the mass, we will need to apply more force in order to accelerate that object. More mass means more momentum. So from this we conclude that the rate of change of momentum is directly proportional to the applied force.